Hello and welcome to today's webinar on enabling intelligent infrastructure to enhance pedestrian and vehicle safety. My name is Ann Insero and I'll be the moderator for this webinar. Your presenters will be Joel White, ITS Vertical Marketing Manager for Bosch, and Bill Corbin, President of MH Corbin. Before I turn it over to Joel, I'll go through a few logistics. All audience lines have been muted to ensure quality audio, and we are recording this webinar and will post it online for viewing later. We will answer questions today at the end of the presentation. To submit a question, please enter it in the Q&A tab in the WebEx platform. You can ask questions at any time throughout the presentation. With that, I'll turn it over to Joel to begin our presentation.
All right, thank you, Ann. And thank you, everybody, for joining. So here we are. This is myself, Joel White, and Bill Corbin. The details of what's going on, as Ann just talked about. And then what we're going to cover today. So you've all joined. We're certainly looking at intelligent infrastructure, but we're really focusing on the values of video as a sensor. So how can you deploy video to do more than just monitor and pay attention to what's taking place on your road? And how that works is through embedded analytics as well as integrations and solutions, which is why we have Bill Corbin here from MH Corbin, as we have integration and have deployed solutions, which we'll talk about as we go further. And then looking at the challenges. I mean, what do our customers and partners at DOTs throughout the US and Canada seem to look at? And then how can you drive more value out of video, collect data, look at accuracy measures, and so on. So when you look at the world today, I mean, many of us face similar challenges. It's congestion, safety. How do we take what's coming in technology, what's been available in technology, and do more to make our roads more safer and more pleasurable for the people that use them? It's all about the communities and the communities we serve, and keeping those roadways safe and flowing freely are really where we're focused. And so how do you do this? Where can video help? How can the solutions we're talking about help? Not only to detect critical events as well as raise awareness, but to do things on their own, as opposed to having a human interact every time there is a possible event on the roadway. So when you look at video, at Bosch we have a certain approach. In fact, I say it's in the camera's DNA. When we build a camera, we build it to be a sensing device. So included in the cameras most commonly deployed in traffic applications, we have two processors. One that does all the typical video encoding, stream generation, scene improvement, and a second one that's custom built and dedicated to analyzing that video and producing a metadata stream. In fact, what we do is right at the sensor on raw pixel data, we're generating the metadata stream before it's encoded and there's some loss introduced from compression. So we're looking at opportunities where in many cases we deploy cameras and we only look at the video to fine-tune analytics setup and to do some validation, but the rest of those time, those cameras are serving as sensing devices, raising real-time alerts and streaming data that can be aggregated over time. So from a single-purpose device, which typically was video, now you can have multiple purposes. Excellent video 24/7. I like to call it world-class video, automated incident detection, the onboard intelligence in the camera itself to detect and raise alerts. And then the third benefit would be that metadata stream can be parsed and analyzed as aggregated data for historical analysis. So here's a look at how it works. This is a deployment. We had a partner in Iowa who wanted to put one of our cameras out on this highway entrance for a wrong-way detection. Now, what's interesting here is he didn't have a big budget. He wanted to do a quick pilot, hang a camera on a pole that already existed with power, put up an LTE connection so we can access the camera. And we remote connected to his camera, configured a dual detection zone wrong way analytic, and designed it to just email the DOT when and if there was a wrong way detection. Now, he warned us up front that this is an area where drivers are confused and unusual for us, but within 12 hours, he's forwarding us this image of a wrong way driver trying to enter that roadway in the daylight, going the wrong way. So this is a true situation that he encounters, how we simply use the camera to sense the event and inform him by email. Not really a full solution. Here's another interesting one. And this happens to be a video that we did in Detroit. This is over 2 years ago. In this situation, when you're on that roadway where the truck is going, you've committed to cross the border into Canada, going over the Ambassador Bridge. Now, as typical with most border crossings, once you're on the ramp, it's one way and only one way, unless you go to enforcement. Now, we have a camera off to the side looking for the wrong way event, and the video you're seeing is coming from one of our MIC PTZs. The detection camera tells the MIC, I want you to move into position and monitor that ramp for the wrong way driver we know is headed your way. So as you can see, camera moved, received the alert from the first camera, and as that trucker's going up the roadway, we're going to track him and another trucker's coming down. So this can be critical. In this case, for the DOT in Michigan, we raise an alert inside the TMC. That's the solution they were looking at. But when you consider that video is a sensor, what did you just see? A wrong way event. This happens multiple times a month in the same location, and we're triggering an event into the TMC. Now, wrong way drivers, they happen often. There are many fatalities annually from a wrong way driver. So how do you create a solution that takes the human out of it? In a call we did with one of our DOT partners a few weeks ago, when she mentioned wrong way driving to us, she said, if you raise an alert in the TMC, by the time somebody observes that alert and then reacts to it, that driver could be 2 or 3 miles down the road. The accident's already happened. So it's too late. So what do you do to make it possible to say, my camera is a sensor, it's actively looking at and monitoring my road, and when it does have a critical detection of an event, what's the solution? So when you think about this, the sensing capability has to be accurate. It has to be reliable. And it has to be thoroughly vetted and tested. Otherwise, you have false positives, false detections that are going to raise alerts that have no need. But when you know you have a confident solution out there, and you know that you have the accuracy level that means let's take evasive action, now you have to create a solution. And that's where our partner MH Corbin comes in. And I'm going to turn this over to Bill Corbin from MH Corbin, so he can then walk you through how they've taken an alert from a camera and developed a solution.
Yeah, thanks, Joel. And thanks, everyone, for taking time to join us today for this webinar. Joel's introduced here earlier video as a sensor, and I'm going to talk a little bit about leveraging all of that data and creating a total solution. As the title of the webinar suggests, that's what we're working towards. We're working towards enhancing safety, and that's where the Connect ITS, which is a device that we manufacture, comes into play. You'll hear me mention it a lot, but the Connect ITS is an edge computing device that's used to gather, analyze, and communicate. And that's really the backbone of the system. And that gather piece is really where we're working closely with Bosch and their video as a sensor. We're able to utilize that Bosch metadata stream. If you remember, Joel mentioned a video stream and a metadata stream. We're taking that metadata stream into the Connect and utilizing different pieces of that, whether it be GPS coordinates, heading, speed, anything like that, for a variety of scenarios. And those scenarios range from pedestrian detection to stop vehicles to wrong way drivers. And the Connect is able to gather that data analyze it on the edge, so we don't have any latency. We're analyzing that data on the edge, and then we're able to communicate it out in a variety of different ways. And that could be, through the TMC or to flashing beacon signs or via connected vehicles. We've got an onboard J2735 software stack that allows us to create TIM messages for broadcast. So here we've got a scenario, kind of a simulation of a possible wrong-way vehicle system, and the Connect ITS is being utilized as the system controller. And one of the things that our systems always have is dual detection. And one of those pieces of detection is always the Bosch camera. But we can use radar, a secondary video, or LiDAR. But we always are looking for that multiple form of detection. And then from there, we can do numerous things. So that first detection point is a warning. And then the second detection point, which is the camera, is verifying that original warning and then generating the alert. And this is really where the systems can be developed or expanded upon. So a lot of times when this happens, the only thing people are doing is turning on some flashing beacons. But with the Connect ITS, we're able to do a variety of different things to communicate to the motorists as well as to the owner-operators. One of our customers wanted to be alerted via a text message. So we added that to the system. Other people want a TIM to be broadcast, so we're able to do that. And then obviously we're able to send emails back to the TMC. But as Joel alluded to, a lot of times by the time it gets back to that TMC operator, the damage may have already been done. So being able to do all this stuff on the edge and communicate this information in a variety of different ways is very important and one of the keys to the Connect ITS.
Thank you, Bill. So when you look at intelligent infrastructure, it's leveraging camera edge analytics capability. Now, the multiple benefits you get out of deploying video can be derived by deploying Bosch solutions and Bosch cameras. The beauty of having intelligence in every camera is you build a distributed network of video sensors. Most all agencies we talk to are deploying video. They want to be looking at conditions on the road and be able to reroute traffic as needed by observing. Most states we're in, most cities we're in, have large traffic monitoring centers with large video walls where this is done. But when you start to bring in intelligence in the infrastructure and you have active monitoring, now you can do things with pedestrian detection. Do we need to warn drivers a pedestrian is in the road? Is there a stopped vehicle? And as you're approaching on the highway, traffic congestion that you need to be aware of before you get there. So instead of having those rear end collisions that happen often, let's try and raise awareness, advise drivers approaching situations that they're coming into an area where they may need to pay attention and use a little caution. Now, third benefit, data. Now, what does road use or my intersection use look like over time? I mean, how many cars are going north to south? How many cars are using my exits? Do I have congestion? When does that happen? So grabbing and analyzing data over time is a valuable asset to looking at future planning and future road changes to address some of the common issues. So we do have a poll. I just ask that everybody read through this. It's do you use video analytics at all today? And there are a couple of options there. We'll hold the poll open for about 30 or 45 seconds, and then you'll see the results. Is it not at all? Not today, but we're anticipating we will. A lot of agencies we talk to are just stepping into this, looking at video analytics and testing them out in pilots. And there are some that are way ahead and rely on video analytics. So let's look at the poll results. All right, thank you. So another interesting aspect as we move into the next use case of what comes through the camera is the camera's ability to generate real-time GPS coordinates. So as I have a camera installed, and this happens to be from what's called the Experience Center for Smart Cities in Columbus, those cameras on the building, which are represented by the yellow dots, are calibrated and know their known GPS coordinates. So every object that moves through the field of view of the camera is represented on the Google map as an object that's classified and detected, those red dots moving. Now, in the piece of software I'm using, I can only display 3 of the 7 video feeds, but the movement of pedestrians, bicycles, cars, and trucks is happening from all the 7 cameras. So as you see this cyclist crossing, his red dot is represented on that crosswalk in the map. Pedestrians moving. So what's interesting here is 15 times a second that GPS data is updated. So effectively you have a real-time presence and tracking solution that's communicating out that data, which can be used for other purposes. Now I will turn this over to Bill, and he'll describe a situation where we have applied this in a solution.
Thanks, Joel. Yeah, so I mentioned I'm from Columbus, Ohio, and a lot of you may know or have heard of DriveOhio and the US 33 Smart Mobility Corridor. Well, along that corridor is the city of Marysville, and the city of Marysville has been testing a lot of different connected vehicle technologies and things like that. And one of the systems that they're installed now, they've actually got 3 separate locations, is a vulnerable road user solution. And what we're doing there is we're utilizing the Bosch thermal cameras. And in this particular picture on the right, that's the City Hall of Marysville. And we're utilizing the metadata stream and those GPS coordinates to track all the pedestrians. We don't care where they are, if they're in the crosswalk, if they're jaywalking, if they're on the sidewalk, we're constantly being fed that metadata stream. And from that, we're able to broadcast out personal safety messages. There are several connected vehicles in the area that are affiliated with Honda. So we're able to send out those personal safety messages, and they get broadcasted and placed on the OBU. So it's a neat system. It's been, it was a pilot deployment that's been in about 12 to 14 months now. We've been fine-tuning it, and we've got it to a point now where with the camera calibration the way it is, the pedestrian placement is extremely accurate. I mean, you can see on this particular diagram the 4 corners. We've got the cameras mounted on the mast arms, and we're able to see almost the full city block. But one of the lessons learned here was the importance of making sure you had the correct field of view, so you're able to get the crosswalks and the cutouts of the sidewalks. It's more important to have a shorter but proper field of view as opposed to the length. But we've really been able to fine-tune this system with the help of the public works director there. And it's turned out to be a very successful pilot project, and looking to expand that elsewhere. Again, this is just a simulation of our system here. Again, we don't care really where these vulnerable road users are located. That metadata stream is going to give us all we need to know. And based on that, the Connect ITS will analyze that metadata and produce that personal safety message. In this particular application, I think we're using a Siemens RSU, but we've worked closely with Capsch and Dan Law and several others, and they've all performed very well. But the key here is we're using that Bosch metadata and the Connect ITS to analyze and communicate that data. And this is a tool, Capsch. I mentioned we were working with Capsch. We're actually the RSU integrator for the US 33 Smart Mobility Corridor project. And we have delivered the Capsch CMCC, which is basically the back-end software system. And this is the exact same intersection as we were showing before. You see the city of Marysville in the center there on the left. And as people walk out of City Hall, they cross that crosswalk. And this is the metadata stream we're seeing from Bosch. And the Connect ITS is broadcasting that personal safety message, which is not only going out to connected vehicles, but we're also pushing it back to this back-end cloud-hosted system of captures. So you can see exactly where these pedestrians are, and it's very accurate. I mean, obviously, we're showing them right walking down the center of that crosswalk as well as right up the sidewalk. So, like I said, being able to calibrate these cameras and have a proper field of view, that's probably the two things that were learned as part of this pilot. But it's really starting to, it's really dialed in now, and the city of Marysville is happy with what they're seeing.
So thank you, Bill. And I've actually ridden in some of the city's test vehicles where you can see that map actively displaying pedestrian positions, signal timing, and other things on the onboard unit. But what's interesting here is concurrent to all the activity Bill just talked about and the active detections, we're also providing the town of Marysville deep information in an analytics dashboard published online of all the pedestrian movements, approaching vehicles, departing vehicles, historical data going back quite some time, almost to the beginning of the year, where they can now interact and get a feel for what happens to be going on their roadway. An interesting story was they questioned me on the accuracy of pedestrian jaywalkers, where we had extremely high numbers of jaywalkers one day, and in reviewing the video to validate the accuracy, it turned out it happened to be on Thanksgiving, where they were having their annual turkey trot race, and all the runners were aggregated in the road being detectors at jaywalkers. So what's interesting is when you start to look at analytics and history, that data can be telling and give you the ability to make some decision-making and other changes to improve how your roads get used. So poll number 2 is, are you using automated systems for real-time data? So many of the agencies we talk to, data is important and critical, but real-time data is also very interesting. So if you could answer this poll, we'll let it run again for another couple of seconds, and then be able to track some results. So one of these options may fit where you are, or, you know, maybe we haven't nailed it and you don't use data. But it would be interesting for us to know where you sit as far as data is concerned. All right, so there's the results showing. Thank you for that, and we will move forward.
Yeah, so as we'd mentioned before, obviously we're closely aligned and partnered with Bosch, but we're also doing a fair amount of work with DriveOhio, which is an offshoot of ODOT, and DriveOhio is really dedicated towards building out and testing connected and autonomous vehicles. So while they're affiliated with ODOT, they're sort of somewhat on their own from a testing and trying to attract people to the state of Ohio to test autonomous and connected vehicles. They've got several projects that are either going on now or have been completed. The one that we're going to talk about most is the US 33 Smart Mobility Corridor, and that's a stretch of roadway that runs from the city of Dublin, which is in the northwest corner of Columbus. It's a 35-mile stretch out to TRC, which is a Transportation Research Center, which does a lot of different testing and are very involved in the connected and autonomous vehicle space. So that stretch of roadway, an ATC MTD grant was awarded to the City of Dublin, City of Marysville, and Union County, and they've since deployed fiber optic along that stretch of roadway. We're in the process of deploying numerous roadside units along there, and obviously the City of Marysville has their deployments, and Honda is located out on the west end of 33 out near TRC, and Honda obviously has been very active in that connected vehicle space. And along this stretch of roadway, we're deploying all types of different infrastructure. We've got several locations where we've got the Bosch video as a sensor, but we've also got other sensors, weather-related, bridge deck sensors, speed sensors. So we're able to deploy a lot of different use cases along this stretch of highway, and it's just in the infancy. We are still in the process of installing all the roadside units, but we have been able to test out and improve some of the systems and some of the use cases. This is at US 33 at Post Road. There is a 70-foot camera pole. Right now you're looking at the MIC camera. But on this particular application, you've got 3 cameras. You've got a MIC, which is their PTZ, and then you've got 2 fixed thermal cameras. One's pointed at a ramp, the other one's pointing at an intersection. And you've also got 3 different weather sensors: visibility, wind speed, and bridge deck sensors. And we're running all sorts of applications out of a single Connect ITS here. We just finished a wrong way vehicle test with DriveOhio using one of the thermals. The other thermal, we're doing collision avoidance. This particular MIC we're using for queued traffic. So that's what we're going to demonstrate here. But the key is everything we're discussing here has been tested and is a real world application. It's a real world end-to-end solution utilizing the video as a sensor in the Connect ITS. So here you see the queue is detected by the MIC, and then the Connect ITS, we do have an RSU at this location. That RSU is broadcasting out a traveler information message. So you see, this is my vehicle here, and we're running our OBU application. So the queue is triggered by the MIC. The Connect ITS then generates that traveler information message that gets broadcast out. And we could do numerous other things with that message. I mean, there's dynamic message signs you can see in the distance. We could activate those. So the possibilities are almost endless here. But I guess the key takeaway from this particular location is the number of applications we're running, and we're doing it all out of a single Connect ITS controller. So a really good application, a really good location for us, and one of many that's going to be along this US 33 corridor once they continue the build out.
All right, thank you, Bill. And similar to the previous use case, we are aggregating and collecting data from all those cameras deployed along the corridor. So we're looking at traffic in the main line. We're doing exit and entry counts on certain ramps. And what we just saw was slow traffic on the Post Road exit. What we're doing is detecting that. Now, when traffic backs up all the way onto the main line, the Connect ITS is going to raise those alerts, but we provide back to ODOT historical information that gives them the ability to look at where did they have the congestion, what times of day, and how does that look historically over time.
Yeah, just to continue on the theme of data, we also have a dashboard that we can utilize for data storage, whether it be live or historical data. It's called Materia. It actually resides on the Connect ITS in this application. But beyond the video as a sensor, I'd mentioned that we communicate with a lot of different other sensors. So this is just a way for us to capture that data. This particular application, we're pulling in a bunch of different weather data. And that can get stored locally, or it can get hosted in the cloud. But it's just another way. You know, there's so much data being generated, and we've got to utilize that data if we're going to be able to expand some of these applications.
All right, so here's a quick look at some of the products that we're typically deploying. The Connect ITS, a couple of cameras from Bosch. We certainly have a wider portfolio of products. We don't want to make this into a product discussion, but give you at least an idea of the devices we're typically deploying in these installations. So just to cover, we did cover a number of use cases, the concept of using video not only for monitoring, but as an active real-time sensor to detect those incidents, to also run in as intelligence and data gathering sensors, whether it's in an intersection, on a highway corridor. There is a solution for deploying video as a sensor that can run many different use cases and then drive improved safety and mobility. So with that, we will take questions.
Yes, thank you, Joel and Bill, for that presentation. As a reminder, please submit your questions using the Q&A tab, and we'll get to as many as we can. Our first question today is, can you discuss the advantages of an edge computing device?
So I'll take that. I think when you're looking at intelligent systems, we talk to a number of different agencies who have deployed all types of different solutions, but when you put your intelligence into the camera and you're deploying a device for multiple purposes, you create a distributed network of sensors. Similar to when Bill talked about weather sensors or pavement sensors, you wouldn't rely on just one. So why do that with video? You can have video that works as an intelligence gathering tool, creating a true intelligent infrastructure without any single point of failure.
Okay, next question. Does Bosch have hybrid and thermal cameras?
So we do. We sell both fixed thermal cameras and multiple focal lengths. And we also have a PTZ that's a combination of true color video and thermal.
Okay, next question. After installing your VRU in Marysville, Ohio, what was the accuracy?
So I did talk about that a little bit in Marysville with the pedestrian detection, but when they raised a question on the jaywalkers and we looked at the video and did some ground truth analysis, we did see it was a particular event where there were lots of jaywalkers. So one important thing is we're continually looking at ground truth. We always want to record video, and we're trying to perfect the solutions, but depending on the use case. So for example, wrong way, we want to see high 90% accuracy and no false triggers. Other cases where I'm counting how many pedestrians in the crosswalk, now we probably are in the 88 to 90% range. So the accuracy can vary, and it really is going to depend on the different use case.
Okay, next question is for Bill. Are you still using LiDAR as a sensor, or have you changed into using media?
No, we still use LiDAR. We obviously, for our wrong way detection systems, to date, we've used video as a sensor and LiDAR as our two detection methods, but we absolutely still do utilize the LiDAR technology.
Okay, for Joel, do the cameras also detect and collect data on vehicle speeds?
Yes, they do. Ideally, you'd want to have a transverse view where the vehicles move across the field of view so the camera has enough time to detect that speed. But in oncoming vehicles, we would put out a speed number that needs to be assessed by running some ground truth and verification in vehicles of known speeds.
Okay, another question for Joel. Is the intelligent video analytics available in previous versions of the MIC camera before the 7100 series?
Yes, we've had analytics in our cameras for almost 10, 15 years now. What happens is we continually improve the capability as we can step up the processing horsepower inside those cameras. So chances are a Bosch camera you've had that has analytics capability in it, there may not be the latest and greatest capability that cameras have. So for example, things like machine learning and being able to train custom detectors is only possible in the more current cameras, but all of our cameras do have onboard analytics.
And what are the advantages, disadvantages of Autodom versus MIC for primary use of surveillance?
So when you're talking about PTZ, the MIC is much more ruggedized and suited for harsh environments. So things like if I'm up on a 70-foot pole, vibration, being able to have a camera that can withstand some of the high temperatures, wind gusts, things that happen out on the roadways. We've had cameras on a new bridge in the New York City area, and the vibration of the bridge has shaken apart not only Bosch cameras, but also others. And today, the MIC is the only camera that can survive that harsh vibration environment.
Okay, and how does the maintenance work for the cameras? Do you need extra traffic control team?
So when we're talking about a MIC, which is always our go-to camera for traffic, we like to say that it reduces maintenance costs because it's not a PTZ with a dome bubble. It's a flat screen. It has an onboard wiper. Many of our customers during the rain, we'll tilt the camera up, get the front glass wet, run the wiper. The latest MIC also has high-intensity defrosters using aircraft windshield defrosting technology. So the maintenance cost is significantly reduced in big tunnels where maintenance happens every night. Typically what happens is the maintenance team goes by with a power washer, wets the camera, and then runs the wiper to keep it clean.
Okay, do the cameras require time to learn behaviors that are observed by objects in the field?
So I think the question is really focused on how do you set up analytics and do they require time? So the analytics engine is a fixed engine, and when I take on and approach a project, generally the analytics that are first set up could use some tweaking and perfection. So for example, in our original wrong way solution where we're using 2 zones to detect a vehicle crossing through not only zone 1 but then proceeding to zone 2, we noticed some false detections. And when we analyzed what was going wrong, though, there was some slight pole shake on the pole where the camera's installed, causing negative pixel movement, which the camera interpreted as a wrong way driver. So by adding some speed filtering and some directional filtering to those detection zones, eliminated all of the false positives we were seeing. So what I like to say is the first time you set it up may not get you exactly what you're looking for. So you got to analyze where you might see things that need to be adjusted, and then use any of the many tools in the analytics engine to perfect your detection accuracy.
Okay, which cameras use deep learning for developing analytics?
We do have some new cameras coming out that will actually use neural networks and deep learning models. So those cameras are just on the near horizon, going into beta testing now. The rest of our cameras up to this point use the machine learning model, which when you compare the deep learning and the machine learning, the accuracy is very close to each other, but of course the machine learning requires some human intervention to get to that point.
Can the camera differentiate between pedestrians and bikes in vulnerable road user applications?
So we can certainly differentiate between pedestrians and bikes. Our bicycle detector today is what we call a two-wheeler, bicycle and motorcycle, as opposed to just bikes. So certainly pedestrians are segmented out and two-wheelers are segmented as well.
Okay, and a question for Bill. Are there limitations to the types of sensors that the Connect ITS can integrate with?
No, there's really not limitations. It really would depend on the communication method. You know, a lot of the sensors communicate over RS-485, some are Ethernet. So if there is a limitation, it would most likely be in an older sensor where we may not support the type of communication it's used. But we have not, knock on wood, we have not come across a sensor that we haven't been able to integrate yet.
Okay. Thanks, Bill and Joel. That's all the time we have for today. We appreciate your attention. You'll soon receive a follow-up email with the recording of the webinar, links to additional information, as well as contact information for both Bosch and Mitch Corbin. Thank you for attending.
Yes, thank you, everybody.